Good morning, good afternoon, good evening, students. This is part 2 of my inflation CPI video series. So this will be going over CPI more in depth. The first video was mostly over inflation rate. And then I started to get into this terrifying chart of what future prices are going to look like. I'm going to finish that chart here at the top of the video, show you guys what stuff like a movie ticket is projected to cost in 2050, as well as a home or college or stuff like that. And then I'm going to go into what CPI is in depth, how we find it, how we do the math for it, and then some mathematical examples of it. So I didn't want the first video to take too long, so I just cut it in half for this part. This is a 2-day lecture for me in class, so it being 45 minutes for each video isn't crazy. I was hoping it'd be faster, but since I have to do all the math for that and show you it, it'll take a little bit longer. So let's get started. This is the part of the chart that I had gotten to in the previous video. So I'd say yesterday. In the previous video. So I'd gotten through these first 3. Now again, how I'm doing this last part is I find this rate of change, which is just through a normal rate of change formula. That's like year 2 minus year 1 over year 1 gets me my rate of change. I take that rate of change, that's X, that's Y. X equals the rate times Y, the number from this column, plus Y, the number from this column. That's how I'm finding what the prices are going to be in the future. So Nike Air Jordans. I picked Air Jordans because it was the thing that had most consistently been sold at a high quantity, and had sort of consistent prices. In terms of its price change, had been fairly consistent over the years. So again, I'm doing 180 minus 65 over 65. No, not 5, over 65. There we go. Tells me that the Air Jordans have inflated at a rate of change of 1.77, which just means the inflation rate there is 177%. You take that number and times by 100 to get your inflation rate. That is almost the exact same as median income. It's the product that most closely rose with people's incomes. $65 in 1987 is pretty dang close to $180 in 2020. Okay? In terms of as a percentage of their income. It's pretty dang close. But let's see what that means, what that's going to be like in the future. Because again, if these go by the same rate, then whatever number shows up here should feel roughly the same to you in 2051 as a normal person buying a pair of Air Jordans does now, which is they are fairly expensive shoes. So what I'm going to do is I'm going to take 1.77 times 180 plus 180. That gets me 498.6, so let's just call it an even 500. It's like 499, but I'm just going to call it 500. It's a squiggle. Yeah, that's about $500. So means that the newest pairs of Jordans, and this is not like resale, this is like normal, everyday Jordans, which is still fancy, will cost on average about $500 in 2051, when your kids might be asking for them for their birthday. Now, you might be making $171K a year on average. $500 is going to feel about as expensive as $180 feels if you're making this much now. So they feel roughly the same. They inflated about the same rate. Gasoline per gallon. This is 2019's gas prices. COVID messed the gas prices up quite a bit. But look at back in 1987, what gas was $1.20 an hour, $1.20 a gallon. Dang. Okay. So 2.66 divided by 1.2. Oh, sorry. Minus 1.2. 2.66 minus 1.2. There we go. Divide by 1.2. There we go. 1.21. My rate of change. Okay. That's pretty dang close to my CPI rate of change. 121% inflation rate, okay. I will take that number, multiply it by 2.66, add 2.66. Cool, tells me that the price of gas, and this is in Texas, for those of you that are wondering where was 2.66 per gallon, it was Texas, right around $5.90 a gallon. That's a lot. That's a scary number to people in Texas. That'll feel less significant than 266 feels now, based on the incomes and the rate of change to that. It'll feel more expensive for you if you're a minimum wage person, because that rate of change is terrible. And 266 to 725 is less than 590 will feel to 1533. So to a minimum wage person, this will feel more expensive. Someone making closer to the median income, this will feel less expensive than it does now. But that's still a scary number to see. In California, a state that doesn't produce most of its own gas, unlike Texas does, you're going to see a little different. So 4 minus 1.2 Ugh. Divide by 1.2. Well, that's not a good number. The rate of change there is 2.3. And again, the rate of change is what you're going to look at to see, will this feel more expensive or less expensive? To the average person would be in this column. To you guys who are mostly minimum wage workers, it's that number that you're looking at. So 2.3, we're taking that 2.33, we're going to multiply. Again, if you're watching this video and you did the math already, just skip to when I have it freeze framed with all the numbers in there, and then I'll discuss how terrifying this is. Do the 2.33. I forgot that I had this slide in here and that I work through with my students, so boy, this takes a while. Normally I have them just do it and I just ask them for their answers, but I can't do that with you guys, so apologies if this takes a decent amount of time. 2.33 times 4 equals, plus 4. Cool. $13.33 per gallon. Jeepers, that's not good. And that's not even taking into the fact that like oil will become more scarce over time as it's a non-renewable resource. Yeah, so that's not even taking into account that part. This is just like, it could just literally be $13 a gallon. And you could be making $15 an hour and paying $13 a gallon for gas if you don't live in Texas. Well, that's not good. TVs, that's a slow rate of change. Actually, that one, prices have gone sort of down almost, effectively. So 915 minus 500 over 500. Like, wait, it's point something. Yeah, that can happen. 0.83 means the inflation rate is 83%. It's less than 100, which is great. It's really small. So I multiply 915, by that. Then I add 915 to that, and I get 1674.55. If I'm making $171K a year in the price of a brand new TV, I mean, this could be like a 4D 95-inch amazing TV. Because like this $500 TV back in 87 was like literally a 28-inch TV. I'm not kidding. That's where I grabbed the average price of a TV, because the average TV sold back in 87 was 28 inches. This 2019-20 TV was 48 inches. And it was HD 1080p. It's like, it costs more, yes, but not an insanely high rate, and also way better bang for your buck. So the TV ones have actually gotten cheaper. That's nice. That's a good word. It's actually gotten more affordable. Movie tickets, if you can tell by rate of change math, are not going to be the same there. Wish I knew how to pause the recording, but I actually literally can't pause the recording. I could go back and edit this, but I'm not very good at editing, so I'll try and edit it to skip ahead. But I'm just going to do the math here. That doesn't seem good. 2.67. If you're wondering why I'm doing this and I don't have them typed up, it's because I didn't have the 2019 numbers in this PowerPoint last time I did it. So I've been doing the stuff fresh. 2.67. Boy, that's a high rate of change. 267% is a lot of inflation. Times 9.15. Okay. Plus 9.15. Okay, average movie ticket would be almost $34, $33.58, almost $34 a ticket to the movies. That's not good, especially if you're making $15 an hour. Like, you already have to pull like 2 hours at your job to be able to afford a movie ticket. You have to pull more than 2 hours at your job to afford a movie ticket here. More, like you have to pull at least 3, and that's not even counting taxes take out of it. New car, that's a big rate of change too. Look at that, 6,000 to 32,500. Now again, cars are a lot better now. There's a lot more going on in the car now than back in the 80s, but there's a lot more going on in the TV now than in the 80s, and TVs got more affordable. Cars look like they got a lot less affordable. 32.5 minus 6,000 divided by 6,000. Oh, sweet Jesus, that's the highest rate of change we've seen so far, 4.41. Don't love that number. We take that number, we multiply it by 32,500. Oh, Jesus, and then I add 32,500 to that. 176,041 bucks. It costs more than you make in a year to get the average car. You're not buying your kid a Rolls Royce. You're not buying your kid a fancy car. You're buying your kid what is a net average car. Now, in fairness, some of you guys might have gotten a new car recently, and it probably costs under $20K. Yeah, because you're getting what is a new car, but you're getting it in the affordable car bracket of like Toyotas and cars that are relatively cheap. This is just the average price of a new car, so it includes the high-end models average with the cheap models. But that's still a significantly high price, because that could mean that the cheap cars are only like $100,000, and that's like half of what you make in a year. More than half of what you make in a year. And that's at median income. That's not at minimum wage. Look at that rate of change and look at the minimum wage rate of change. Not anywhere close to keeping up. One, helps explain why your parents might have been able to afford a new car when they were in high school, working their minimum wage job, and you can't, because this is the rate of change they experienced. This is not a number that I'm making up. This is what happened from 87 to 2019. This is what happened the last 32 years. I'm just saying if it happens again at the exact same rate that it happened previously, what might be happening here? Now, it won't happen at that same rate of change. Like, it literally won't, because, like, randomness, it won't. But if it does, if it just does the exact same thing it did, it's a terrifying sign. New home in Texas, if you're not from Texas and you're watching this video, this will probably upset you that a new home in Texas in 2019 averaged being $270K. There are parts of Texas that are really cheap. Texas is the big state. 270 minus 90. Should be able to do that in my head. Don't know why I'm doing that in a calculator, but whatever. Divide by 90. Again, don't know why I'm doing that in a calculator. That's just literally 2. Rate of change of 200%. 2 times 270 plus 270, which is really just 3 times 270. Average new home in Texas will be $810,000. Okay, when that's the median income, $171K, that being the average price of a new house, it isn't crazy, seeing as like median income now is $62K and the new home in Texas is $270K. Like, this to this and this to this feel similar. And that's because 1.76 and 2 are not terribly far off. Now, this is bigger. This to this is bigger. It will require more work for you to buy a home at that rate of change in 2051, but not by a ton. By 0.25 in the rate of change formula. The college ones are where it gets kind of worrying, because this is one that's very reasonable to expect. That, like, hey, if you are going to have a kid and you're in my age group, you already probably know that college got a lot more expensive. But look at this, 87, it was 5.8. This is not just like tuition. This is tuition, room, and board, whole thing. This is how much it costs on average to go to college for a year. Again, tuition plus room and board at a public university in Texas. Again, to be clear, this is in Texas. 5.8K in 1987. At that minimum wage, you can actually almost afford to do that just pulling enough shifts. Like, that's actually attainable. This, my students already probably know, is not reasonably attainable. The rate of change there doesn't keep up, so let's look at it really quickly. The rate of change here is 24,000 minus 5,800 divided by 5,800. 3.14. It's not pi, but it's close. 3.14. That is bigger than everything we've seen except for the car part, and at least part of the car part could be explained by, cars are a lot better now. They're a lot safer. Some of them self-driving cars, luxury cars of 2019, 2020 are insane compared to the luxury cars of 1987. Okay? So like, at least this part you could say technology is a big component of that. Price of making the cars gone up. There's a lot more car companies that make crazy cars. Everyone needs a car now, so demand's really high for cars all the time. Blah, 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 blah. The college one is insane. Then we do the math here. 24,000 times 3.14 plus 24,000 means that, I'm rounding a little bit here, the average cost per year of public college when your children might be going to college in 2051, 2052. If you're a high school student at this point, it's very reasonable for you to have kids that are going to college in 2051. That's 31 years from now. It's entirely in the realm of possibility. It would just mean you have a kid in the next 14 years, which isn't crazy. It's very possible they would have to pay $100,000 per year for room and board to go to college, while you're making, at your average normal job, not minimum wage job, at like a real salary job, $171K a year. Cost your kid $100K to go to school. It costs you $810 to buy a home, $176 to buy an average car. That number does not feel sustainable, and we haven't even gotten to the worst version, private school. 60 minus 13 divided by 13, 3.62. It's even bigger. I take that, I multiply it by 60. I add 60. $277,000 per year for private school. If your kid wants to go to TCU or Baylor or any private college and graduate in 4 years on a normal academic timeline, it'll cost them over $1 million at the current rate of change. If prices of college go up by the same amount that they have since the 80s. Not to say that they will, they don't have to, and I can't really imagine demand for college getting any higher. But more people keep getting born here, and more people keep going to college every single year, so demand has been increasing and seems to keep on increasing. It doesn't feel culturally like it can get any higher, but numbers-wise, math-wise, it still seems to be. So this is the part where people might be coming back in. It's like, here are our numbers. Let's digest and talk about those before I get into the CPI bit. I know we're 15 minutes into the video and I've only done this math, but this is important to look at and talk about. So what we're looking at in that table, what we're seeing, what we're finding is a couple of things. One, some things, prices have been fairly reasonable and sustainable. Shoes like Air Jordans are fine. Gasoline, if you're in Texas, has been fine. A TV has actually been a really awesome deal. Like, you're getting a crazy good deal on TVs now. Median income has gone up by 1.76 is the rate of change. That's pretty good. For a lot of countries, well, that's pretty good. That isn't the problem. And to be clear, I cherry-picked some numbers here. Don't freak out thinking everything is going to get more expensive. Your average stuff is actually going to get more affordable, like the TV and like food and stuff. Looks like it's going to get more affordable. The rate of changes of those things was actually like below. I mean, the fast food burger, 1.3 compared to median income of 1.76. It's going to feel cheaper. It'll be fine there. But a lot of things that are necessities for people, buying a home, buying a car, going to college, those have not gone up by a sustainable amount over the last 30 years. They haven't. And your parents probably know that, or at least if they don't know the numbers, have felt the consequences of those numbers, where when they were planning for the future, because think about it, if you're planning on having a kid, it's probably smart to think about how much things are going to cost when your kid's trying to pay for things, and how much you might be getting paid when that's happening. It's good to plan and be reasonable and possible. Sorry, my camera feed stuff is over on my right screen if I'm looking over there a lot. But when you're trying to do that, not taking into account inflation could be suicide financially for you. Because if your parents were game planning around you going to school with the same price of college that they had paid in mind, there's no way in hell they would be able to have enough money to pay for you to go to college, right? There's just no way. And I wouldn't even be able to hold it against them, because 300% is the inflation rate of that stuff in 30 years. My dad graduated college in 1984. He graduated from University of South Carolina, public university. He was paying right around this $5.8K a year for room and board and tuition, all of it, all of the cost of college back then. If he had been putting money into a college plan, because my parents did not. We were not making enough money for us to be able to do that growing up. But if he had been, if he had just put in what he was expecting, he would have had enough money saved up for me to pay for just barely 1 year of college. Not even a full year. 5.8 times 4 gets me under 24K. Wouldn't have even had a full year of college paid for then. I wouldn't have. So what we've got to understand is that some of these numbers are not sustainable. If they go up at this rate, our economy will suffer significantly. It already has suffered for this. The student loan crisis is a massive problem in this country, and this is sort of numbers that help reflect and prove that problem of no, it's not sustainable. Our incomes haven't kept up with this. Our minimum wage is not anywhere close to keeping up with this. That's at 1.1, And the last time we raised that number federally was back in 2008. It's been 12 years since we raised it. Think prices have gone up by 3% per year on average. It's been 12 years since we last changed the minimum wage federally. This isn't like a make the minimum wage a living wage argument. This is just math. Saying, hey, it should at least correct for inflation. Maybe you tie it to the median income rate of change, where like maybe we make the minimum wage go up by 1.76 in this time period as opposed to 1.1. That way people who are in that threshold, their income is keeping up with things like food and essentials and TV and shoes and stuff like that. It won't keep up with buying a new car, buying a new home, or paying for college, but it'll get them closer to those than they're at right now. So that's where inflation matters. And that's where I give the kids a panic attack. Because when I do that math, when we show them those numbers, if you're watching this video and you're getting freaked out, it's the right headspace. Take a breath, pause the video, breathe. Okay? It's freaky. It's really freaky. Okay, but your parents experienced this. So when we're talking about like, this is unrealistic, it's not unrealistic. It's what happened. Now, will it happen again at the same rate? No, I can guarantee you it won't happen at the same rate. But it could happen at a worse rate if we don't do anything. Okay, things like college, the government can step in on. Like public schools, the universities, it's state controlled, it's government controlled technically. So they could very easily put like a cap on that number if they really wanted to. They don't, because colleges want to make money, because they're still an institution that is run by money. But they could reasonably be like, hey, we cannot let the price of tuition exceed $10K a year. Then boom, that'll shrink this rate of change a lot. Cars might become less essential if things like remote learning and remote teaching and remote work become more available and more of an option. Cars might not be as required, so demand could be going down, prices could drop there. TVs are becoming cheaper and cheaper because people don't need them as much. Computers are fitting that place. Phones are fitting that place. All that stuff. Movie tickets, they're getting more expensive, but a lot of movie theater chains are probably going to shut down after the COVID stuff. They're going to go bankrupt, and frankly, who cares? Right? There's a lot of things like that where you can get away with prices not changing at the same rate, but we got to be very careful and very, very cognizant of what's happening there. Okay. On to the next thing. This is the part where I teach you the new stuff, the CPI stuff. I know it's 20 minutes of me talking about scary numbers math, but that's important, scary numbers math, I think. So, back to not being freaked out by things anymore. This is not scary. Sorry about that, but it's an important thing that I think I teach that I think is really, really essential to know. So CPI, the Consumer Price Index, again, that is the price of it's the weighted average of the price of a market basket. It gives us an idea of how much inflation happens in each year. Who made it and why? Short answer, it's made by the government. Specifically the BLS, which is the Bureau of Labor Statistics. They're guys that collect number on things like unemployment and inflation to try and help the government guide policies towards welfare a lot of the time. But they also help the government figure out COLAs, and I mentioned that in the last video. That's a cost of living adjustment. It's a pay raise that people get annually each year to help offset for inflation. Cool, it's an important number. It's an important data set because that helps the government, because the government employs more people than any other entity in the United States. Okay, there's over 30 million people that in some way, shape, or form work for the U.S. government, myself included. So they need to know how much inflation is happening to adjust those people's pay. What they do is they use what's called an index method. If you're a math nerd, feel free to look that up. If you're bad at math, don't bother looking it up. It'll only confuse you. Now, they measure a bunch of stuff. There's 211 specific categories, over 8,000 individual items in different geographical areas of the United States. Those areas matter because like the price of lobster in Texas versus the price of lobster in Maine varies a lot. Gasoline in Texas, we saw, is a lot cheaper than gasoline in California. So having the different areas is important because you sort of want to localize things a bit to make sure that like, hey, Texas might experience 4% inflation this year, but maybe California experiences 5% because the specific prices of those goods are hitting harder in California than they did in Texas, right? That can matter. There are also different versions of CPI. CPI-U, CPI-W, CPI-E, and CPI-U. CPI, or CCPI, sorry. CPI-U is the most commonly used one, and that's the CPI of urban consumers, people living in cities and suburbs. It's how much inflation people in cities and suburbs experience across the nation. That's 81% of our population as a country. So that's probably like the most broadly applicable CPI. CPI-W is the one used for people who are workers, basically. How much do wage earners, people who get paid for a living, how much inflation do they experience on a day-to-day basis. That's important for things like adjusting pay raises. You probably want to know what CPIW is because it's those are the people that are getting paid. How much inflation are they experiencing? CPIE, other people buy different stuff. Change CPI is when it's inflation rates as they change for items that are connected. So like when it's the price of steel goes up, that'll also cause the price of anything that involves steel to go up. Is that an inflation of all those goods at the same time, or is that really just inflation of one good that then happens to affect other goods? Change CPI takes that into account. It's a way more complicated number. It's way harder to find that. And because it's way harder to find that, it can be finicky in terms of accuracy. But if it's accurate, that is actually a much better metric. It's just hard for it to be accurate because you have to know like where each company gets their stuff. That one's really tricky. Now, quick game in terms of think really quickly, what are the top 10 purchasing categories of consumers in the United States? What do people spend the most money on in order? Go. Sort of like a bell ringer activity of like, hey, what do people spend their money on? What's the top 10? What's the ranking? Okay, number 1 is shelter. Shelter is number 1. People spend more money on keeping a roof over their head. Think of where most of their money goes towards rent. Yep. So it's number 1, shelter. Number 2 is transportation. If it's not your house, it's the most expensive thing you own. It's probably your car. 3rd is medical. Medical is 3rd. That's because out-of-pocket medical costs are insanely high in the United States. Not everybody has health insurance, and even if you do, it doesn't necessarily cover you. Also, that includes insurance payments, so that's a lot. 4 is education and communication. Yeah, why are those linked together? Great question. I don't know why they're linked together, but that's school, college supplies, school supplies. Also, communication includes phones and computers. Again, why are those labeled together? Question mark, I don't know, but that's 4. 5, food at home. 6, food away from home. So people spend a little more on groceries than they do on overall food. This is as a country. You might spend differently, but consumers on average do that. Recreation is 7. It's going out, movie theater, sporting events, arcade, having fun. Bars also apply there. Apparel, clothing, is 9 or 8 or 9. I'm missing one here. No, this is right. I said mislabeled one at one point. But apparel and then personal care products is last on the list. Personal care. Oh, utilities. Sorry, utilities is 6. Yeah, no, 7. Food at home, food away from home, then utilities. Sorry. Utilities is after food away from home. It goes utilities, recreation, apparel, personal care products. That's the order on our spending. Now, some problems with CPI to be aware of when it comes to like AP exam questions and stuff like that. CPI just gives us this average. It says, okay, this market basket, those 8,000 items that consumers buy, what happens to those prices? And again, we mentioned if like CPI is 114 this year, that means that compared to the base year, prices have gone up by 14%. You're always comparing to 100. But some problems with that. Technology, like phone prices have changed a lot over the last 10 years, but that's not just the prices going up thing. That could be like technology's gotten better. Your phone does more than just call people now, so it should go up. Ditto for things like a car. We mentioned that car had the highest rate of change on there. Yeah, but cars have like built-in computers now, GPS systems. Some of them can drive themselves now. Safety is significantly better, so like it doesn't reflect changes in technology. Inflation also doesn't really reflect that either, but CPI definitely doesn't. Okay. It also, this isn't on this slide, but I mentioned it when I looked at GDP deflator. CPI is only for consumers. It is the consumer price index. This does not show how much inflation businesses experience when it comes to them buying stuff. It doesn't show how much foreigners experience when they buy from us. So it doesn't cover like everything in an economy. It only covers the consumer portion. So that's important to mention. Another problem, which only is really a problem for me, is, well, it's a problem that you have to know for the AP exam, but it's a problem for me personally, is that the Bureau of Labor Statistics uses the CPIW to determine cost of living adjustments. And I mentioned that makes sense logically, because you're like, that's the inflation rate that people who earn a living experience. And like, cool, I earn a living, so I experience that, so that's how much inflation I deal with. The problem is that's a lower inflation rate than the CPIU shows. And 81% of people live in urban areas. So the majority of people live there, overwhelming majority. By using CPIW, the government kind of skimps some money. They don't pay people as much of a raise as they could reasonably argue. Now, you might say, like, it's justifiable to make that pay cut, which is not inaccurate. It is kind of justifiable based on the number. But it is a pay cut. It is less of a pay increase than you could actually feasibly get. Okay. This slide, don't freak out. This is just the writing out of how do we do CPI and why do we do CPI as opposed to just brute force inflation rate. So here's the example. A family of 4 in 2006 spends $48,398 as a national annual average. In 2007, on the exact same stuff, the average family spent $48,898, $500 increase. So if you're going to use inflation rate, which to be clear, this year later minus year earlier over year earlier equals rate of change, and then rate of change times 100 is inflation rate. If you just do year later minus year earlier over year earlier, then times 100, that'll get you the inflation rate of a thing. If we did that, we'd find that there was roughly 1% inflation in between those 2 years. But those are really high numbers. It's a really weird numbers. 500 as a difference is nice, but like, it's not going to be that clean every time, right? Right. So what we want to do is use CPI instead, because those numbers are a lot cleaner. You get numbers for CPI like 100 was your base year CPI every single time, and your CPI next year could be 104. I might not want to do 48,898 and 48,398. I'm pretty confident I can figure out 104 and 100. That's just 4. And then I can do some division and a multiplication off of 4. That's a little easier to deal with. So, I'm going to write the CPI and formula. It's on the next slide, I think. Yeah, there it is. I'll come back to that previous slide. The CPI, the way you find it mathematically in a problem is you take the price of a market basket currently, whatever the price of the market basket is right now, in the sake of the question. You divide it by the price of the market basket in the base year, and you multiply by 100. The CPI of your base year will always be 100. So let's run through the logic of that. It says assume 2000 is the base year. I should say is the base year, not in. But that's my base year, is 2000. So if I'm finding the CPI of 1999, what I need to do is I take the 1999's market basket price, that's 40. I divide it by 50. That's the price of my market basket in the base year. My base year is 2000. The price of it then is 50. 40 over 50 is 4/5. That's 0.8 times 100 is 8. What the heck does that mean? I'll show you. CPI of my base year will always be 100. So I already know this is 100, but if you want to know why it's always 100, if I'm trying to find 2000 CPI, I need the price of the market basket in 2000, that's 50. The price of the market basket in the base year, my base year is 2000, the price is 50. Oh, 50 over 50 is 1 times 100 is 100. So the reason why the CPI of your base year is 100 every time is because you're comparing it to itself. You're saying, okay, how much did prices change by from this year to this year? And the answer is it didn't. That's why it's 100. Not that the rate of change is 100, but that like the sort of barometer is 100. What this means is that from 2000 going backwards to 1999, prices in 1999 were 20% lower than they were in 2000, right? 20% of 100 is 20, so 80 is 20% lower. That logically checks out because 20% of 50 is 10 and prices were $10 lower. That's why CPI can be useful. It can save you time because if I'm told this and I don't know what these numbers are, it tells me, oh, compared, if I look backwards, then prices were 20% lower back then. Got it. Looking forward, 55 over 50 times 100, that should just be a number that I could think of in my head, but I'm not going to. It's 110. This one's 120. This one is 200. Now this one being 200 is 100 over 50. That's 2 times 100. 200 means prices went up from 2000 to 2005. In this example, this is hypothetical. This isn't real numbers. Prices doubled over that time period, which, yep, price of market basket doubled. That tracks. That's why CPI is better. It's because when I look at CPI, it already sort of gives me an indicator of, oh, okay, then prices went up by 10% from 2000 to 2001, 20% from 2000 to 2002, that kind of thing. It helps me do math that is easier to deal with than dealing with large-scale numbers. Let me go back one slide and see if this is easier to explain. This is just how the index method works. If you want to watch a video over it, watch it. It's complicated. I don't really need it. I sort of do this and I can figure it out from here. Now here's a practice problem. Find the CPIs in each of these columns. So what's happening is we're changing the base year with the different columns. So when we said it's price of market basket current year over price of market basket base year times 100, still do that. Just know that your base year might change. I have the 100s filled in automatically because, again, the price of the market basket in the base year, or the CPI in the base year, will always be 100. So if it's base year 2009, the CPI of 2009 would be 100. If it's base year 2010, the CPI of 2010 would be 100. Base year of 2011, the CPI of 2011 would be 100. Blah, 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 blah. So pause the video, find the CPIs for the rest of these columns. You did it, yeah, okay, great. So going down the line, if I'm finding the CPI in this spot right here, I would need to do 40 over 20 times 100. That's just 200. And again, logically, what that's telling me is that, okay, prices from this year to this year went up by 100%, means they doubled, and yep, that checks out. And then for this one, 50 over 20, well, that's 2.5. Prices went up 150%. That also logically checks out. Here, this one, to find this one, I'm doing 20 over 40 because I'm taking the price of my market basket in 2009 and I'm putting it over the price of the market basket in the base year, and my base year is 2010 for this column. So it's 20 over 40 times 100. That would be 50. Because 20 over 40 is 0.5. 0.5 times 100 is 50. How do I read this is, okay, from 2010 to 2009, so going backwards, prices dropped by 50%. Yes. Looking at that perspective, that is true. From 2010 to 2009, prices went down by 50%. Going backwards. And then for this one, it is 50 over 40. That's 5 over 4. 5 fourths, 1 1/4, 1.25. Prices went up by 25%. That also checks out because 25% of 40 is 10. Prices went up by $10. And then for this one, I do 20 over 50, 40 over 50, and those would be my CPIs. If you got that math, you are finding CPI correctly. If that math is not clicking for you, or you don't understand how to do it, practice it. Test out numbers. Just plug in a chart and test out numbers. Okay. The logic you have to be able to do is to figure out what is inflation rate. And again, I don't know if it's even on this PowerPoint. It is in my notes somewhere. Let me make sure that I have it. Yeah, finding the inflation rate. Inflation rate uses the rate of change formula, which is the year 2 minus year 1 over year 1 times 100. It's that formula. That's how we find the inflation rate. So I plug in the CPI of year 2, subtract the CPI of year 1 over the CPI of year 1 times 100. So here's my setup. 125 minus 100 over 100 times 100. Any math whizzes would be able to figure out, oh, I can cancel that. 125 minus 100 is 25%. So a lot of the times when I'm dealing with CPI, I don't even really need to use that formula. If I'm comparing to the base year, which is what I'm saying here, if I compare to the base year, I don't really need that formula because the base year CPI is always 100. Cool. If I'm saying, okay, well, how much inflation happened from the base year to this year? Great, that means the base year is my year one in this formula, and it's going to just cancel out, and now it's just a subtraction problem. That's why I said, if the CPI is 104, that means since your base year you've had 4% inflation. If your CPI is 111, that means since the base year you've had 11% inflation. If your CPI is 200, then since the base year you've had 100% inflation. But what if you don't compare to the base year? This should say year 3. That is a typo on my fault. That should say year 3. CPI for year 2 is 125. CPI for year 3 is 150. What is the inflation rate between these 2 years? It's not 25%. You do the formula. $150 minus $125 over $125 times 100. $150 minus $125, that's $25. 25 over 125 is a fifth, or 0.2. 0.2 times 100 is 20%. That's where you can get caught. You don't ignore this inflation rate formula. You don't have to use it if you're comparing to the base year, because of that 100 thing. But if they're having you compare any 2 years, you do need to do year 2 minus year 1 over year 1 times 100. For this one, it says year 1 is 80, year 2 is 100. That does technically mean that year 2 is the base year, but it's asking what's the inflation rate between these 2 years. I need to do 100 minus 80 over 80 times 100. 100 minus 80 is 20. 20 over 80 is 2/8, which means it's 1/4. That's a 0.25, so that's 25%. So be careful. When you're doing inflation rate, you use this here formula. Year 2 minus year 1 over year 1 times 100. What I'm plugging in for the year 2 and the year 1 is the CPI. It'll also work with GDP deflator. You can use GDP deflator here in place of CPI if they gave you that instead. It works the exact same way. Or you just plug into this year 2 minus year 1 over year 1 times 100 formula. How are we doing on time? Amazing. See if I have my answers on the slide right here. I do. Pause the video. Solve this one. This one is trickier. This one is the big brain part of it. This is the big brain part of it. I'm just going to start plugging in the answers here. So how I did this is I actually worked backwards. The first 2 I do are these 3. I plug in these 100s across the board, easy. Logically, then what I look at is inflation rate. From 2009 to 2010, that means that prices went up by 25%. Cool. It's 25% of 40. 10 went up by 25%. That should be 50. From here, prices went up by 100%. That means whatever is here needs to be double what number is here. That'd be 50. From there, I can start to plug numbers in to my formula. I do 100 over 40. It's 10/4, which is 5/2, 2.5. For this one, that'd be an 80. And for this one, it's actually just the same as my far left column, 40, 50, and 100. So from there, you just start plugging and chugging, going backwards and working through it. But the way I found the first 2, these 2, the way to find these 2 numbers is to do the first 2 bits of it, which is, let me erase it. these three I can plug in immediately. Base year 2009, CPI in 2009 has to be 100. Base year 2010, CPI in 2010 has to be 100. Base year 2011, CPI in 2011 has to be 100. That I already know. From here, it'll be, okay, 25% increase. What's 25% of 40? 10 should be 50. 100% increase, 100% of 50 is 50. So it's 100. That's how you do those problems. This is far and away trickier than I think any AP exam question could reasonably get you, but if you could do that slide, then you've got no problems on finding CPI, understanding the math part of this equation. Okay. That was pretty long. Those were two fairly long videos. Again, in my classes, to be over the course of 2 days, each of my class periods are 45 minutes. These two videos were about 45 minutes each, so that actually worked out time-wise, lined up kind of perfectly. Spent a long time doing math that in my class I'm not usually the one doing. My students are the ones doing a lot of that math, but since I don't have any students to go off of for this, I kind of have to do it myself, and I don't have them built into these slides. I have them on like a worksheet at home, or at my school actually, not at home. I'm at home right now. But there is CPI and inflation rate. So remember the big lessons of like, what is inflation rate? How does it work? Why does it matter? Who is helped and hurt by it? That's stuff to review. Make sure you understand that. The government uses CPI. What is CPI? Like, what does that abbreviation stand for? What does it really look at? What does it mean when you have a CPI of like 104? Like, what does that tell me? What does that mean logically? If I saw that in the news, how would I react? What am I thinking? Okay, those are sort of like the AP exam stuff. The real world stuff is to be looking at that table that I spent a long part of this, probably about half of this total video, working through and thinking, okay, we actually kind of need to have some real world discussions about how that's going to work out. Okay, having them in this video isn't super conducive, but thinking about them on your own, talking about it with the people around you, thinking about government and political office and stuff like that, and things that are on the table that need to be on the table in discussion are super important. Okay, that is it for what'll be this week's videos from my class. Next week I will be having stuff over unemployment, and I might be doing a little bit more on just practicing some math stuff. But that should be it for the math for the unit. That is really all the math for this unit is the GDP PowerPoint, which is frankly a ton of stuff. And then from this PowerPoint, how do you find CPI? How do you find inflation rate? Those are the two big things off this in terms of math that you have to be able to do. Cool. Thank you guys for watching as always. Really appreciate it. You guys have a great rest of your day.